Okay, all right. So what we're gonna do is this today. We're gonna start a new unit, all right? Even though it's funny because unit 10 is all about the quadratic function, right? Meaning using FOIL to take two roots, right? To create a quadratic function. Unit 11 is the exact opposite, okay? And that's what makes it kind of unique. Is that we're gonna since we spend the entire 10th unit, all right, unit 10 on multiplying polynomials, we're gonna spend the entire Unit 11, undoing everything. Okay, so let's see what that looks like. Okay, all right. So as I alluded to, probably, hopefully in class, that for this unit, really because of the time factor, it isn't just the unit itself, all right? And trying to get those of you who are interested in taking the regions to be ready. The videos from now on, all right, and this is a very general rule, the videos are gonna be closer to 20 minutes than 15, even though I've been pushing 20 minutes on almost every video for a while now. So, and I just wanna, tell you ahead of time. All right, so what's factoring, right? Gonna give you an example, all right? In the last unit, right, unit 10, right? So unit 10, right, we were doing things like these, right? Distributive property, multiplying polynomials. So for example, right, here we got 2x to the second plus 3x, right? And then here we'll do FOIL first, outside, inside, and last, right? So we got x squared minus 2x minus 8, so on and so forth, right? And I'm not going to do the last one, all right? Ditto, same thing, all right? Now, what's this unit all about? This unit's all about taking these expressions, like the finished product, the answers from last unit, and turn them back into the questions. So isn't that interesting, right? So we're taking everything we learned, and we're gonna look at the answers for each one of them, the simplified form of the answers, and turn them back into the original, okay? All right, I'm just trying to see how many more arrows I can possibly draw in one lesson. All right, we're gonna turn them all back into this, okay? So that's the challenge, and that's also where the fun is, okay? All right, now hold on, let's see. I'm not sure why this graph is here. Is there any purpose for that? I know what I was trying to do. I was trying to show you that if you hold on, the lights just went off. I was just trying to show you that if I take like a graph like this, right, and I draw it, I can actually tell what the original answers were just by looking at the roots. Okay, so that's the connection from unit 10. All right, now having said that, here's some ground rules, okay? Because like I said, no, I never said this. It's really, how do I say it? This unit's gonna be kind of tough, okay? I'm just gonna say that. All right. That's why this is, why do you think that this is the last unit in your last year of the last month at MS51, right? This is like the, this is the highest point, all right, of what we're doing. So what are some of the rules? Don't get caught up with the don't get caught up with the rules, okay? It's a lot of different ways to solve something, okay? Now, why did I tell you not to get too caught up with the rules? Because most of the methods that we use can lead to the same answers, all right? It's a lot of different methods, okay? I could count like 4 to 5, like just off the top of my head, all right? So what does that mean? Pay attention to every lesson, because you never know at what point you have to use every skill you learn in this unit to find the answers or the roots or the zeros. Okay, all right? Don't memorize the steps. Just practice as many questions as possible. Practicing is what allows you to get used to seeing all the different methods, and it allows you eventually to develop some flexibility with answering these questions, okay? And you really know what you're doing, you've achieved mastery in this unit, is you can look at the question, and just by looking, you can see, oh, I know what they're trying to like. I know what they're trying to do, and I know, and you, not only can you sniff out, right, what the person is up to, right, the person who writes the question, At that point, you will probably have some fairly good idea as to what strategies you can use to answer that question, okay? So that's when you know like you really mastered the topic, okay? So keep that in mind. All right, that said, we're gonna talk about factoring, all right? And this is case one. Write it like this, by the way, okay? Write this in your notebook. Write it like this because I want you to keep like a really good set of notes for this. So dedicate one day worth of notes, like one page to case one, and then case two, case three, so on and so forth, okay? It's a lot of cases, actually. Now, in order to help you solve case one, and this is the most basic one, let's rewind, all right? Let's rewind a little bit, flashback to the 7th grade. Now, in the 7th grade, your teachers probably toward the middle of the year would ask you to look at this, because think about it like this, right? The question is something like this. Can you factor this out using the greatest common factor? Wow, that's a blast from the past, isn't it? Greatest common factor, right? Factor this out so that you could kind of write the question for this, if this were the answer. So what's the greatest common factor between 5x and 25? Yeah, 5, right? So how do you do that? You divide this guy by 5 on both terms. What would that look like? Well, 5x divided by 5 is just x, right? Because the 5's cancel out. 25 divided by 5, I keep the subtraction sign. 25 divided by 5 is 5. And then what's the last thing? Write the GCF right outside. And that would be your quote-unquote answer. So think about what I've just said, right? Turning all these expressions, all right? Let me see how many more arrows I can draw. Take all these expressions and turn them into the original. Okay, that's what we're doing. So that's what we're doing here, right? We're taking the answer and turn it back to the original. Okay, got that? Now, so here's the thing then, right? And in some cases, doing factoring with quadratics is actually easier. What do I mean by that? Well, look at x squared and x. What do they have in common, right? You can't really tell right now. And especially if you're sticking to what you learn about like terms, right? Same family. You wouldn't even think that these two are related, right? X squared and x. But watch this. So what I'm going to do is I'm going to break each of these parts down. And I'm going to like lay it all out. You know, kind of like a video when you watch when someone takes apart a toy and they lay out all the parts on the table. That's what we're going to do to this expression right now. Okay, so what do I mean? How do I get x squared? Yeah, x times x, right? Like that, right? And I got a plus sign. Now, break down 2x for me. What is that? How do you get 2x? Yeah, you take 2 times x, right? Now that you see this, upon further inspection, all right, I'll use my magic pen. Upon further inspection right here. Okay, nothing's happening. So something's supposed to happen. Yep, there we go, all right? Upon closer inspection, right? What do these two terms have in common? Looking at it like from this perspective. Yeah, they both share x, right? So if they both share x, okay, I don't know how to get out of this. I'm using like 2 tricks at once. All right, hold on. Uh-oh, how do I get out of this? Uh-oh, hold on. Let me press pause. All right, and I'm back. All right, so what does that mean? It's kind of like this. It's kind of like what we just done here, right? You factor the x out, right? So I'm going to extract the x, all right? So what's the best way to draw that? All right, I'm going to attempt to draw it like this. I'm going to take these two x out because I know that x is a common factor, right? You see what I'm doing here? I'm just following my blueprint down here, right? I take the x out. What am I left with, right? Because this is gone. This is gone, and now this is gone, right? I got factored out down here, right? So what does that mean? I'm left with x plus 2. Here we go. Now, can you check to see if your answer is right? Sure you can, right? Look. X times x, x squared, x times 2, 2x. Same thing, right? So you know you're good here, okay? All right. Now let's try another one. All right, let's look at this one. Right, now let's break it down. So again, I'm gonna break it down. Now, sometimes with like the 4 and the 7, if this were an 8, right, you know you could factor the 4 out. But right now, I'm not gonna do that because I wanna make sure you're just focusing on the variables. All right, so we got that going. Now, let's break that apart. So we got 4 times x squared, right? So that's x times x minus, right, 7x, 7 times x. Now, look again, all right? What do they have in common? All right, so put your spotlight here. What do both terms have in common? Yeah, x, right? They both got x, and that's it, right? So let's get x out, right? Let's extract it out, like a vanilla extract, right? X. Now, you can't take x squared because this guy here doesn't have enough x's to give you x squared, okay? So you can only take one x out over here, all right? And then we got 4. So we got 4x minus 7. That's it. Took everything out. That's it. This is as good as it gets. Okay? All right? Got that? All right? Now, let's do one more, and then I'll let you practice, and that'll be it for today. All right? Wow, might be a short video. Okay. All right, one more. Now, again, let's break it down. 8x, right? 8 times negative 8. Let me rewrite it. Negative 8, right? Times x squared, so that's x times x, plus 3 times x. Again, all right? I know what some of you are thinking. You're thinking, man, this is like very labor intensive. The more practice you get with it, the less labor intensive it is, because you could pretty much see, like, I'll give you an example, again, using myself as an example. Like, probably after a week of doing this with practice in high school, as soon as I see this, I know that the only thing that can come out is the x, okay? And I can show you different, I could try to show you different examples later with that. All right, so I'm just gonna cross them out. All right, so I don't have to look at it again. And then what's left is, I got the x, right? And then negative 8x plus 3. That's it. And you can check your answers, right? Remember when I said you can just distribute and see what the answer is, okay? And that's considered simplest form, by the way, all right? Simplest form. Okay, now let's see. You know what I'm gonna do now? Let me give you a chance to do, how many questions I have? I got 6, so let's do 3 at a time, okay? So try these 3 right now. I'll use purple, yeah? Try these 3 right now, and when you come back, I'm not gonna say much, I'll just do the questions for you, okay? All right, so take a pause right now. All right, okay, and we're back. So here, I know that they're both x, right? So x has to get drawn out, all right? Now, watch what I do and listen at the same time, because when I'm writing, I'm telling you what I'm thinking, okay? So writing is a very small part of it. I want you to know what I'm thinking when I do these questions, okay? So again, now I see that they both have x, right? So x is gonna come out, all right? Oh, by the way, so you know what? Should I address this here? No, I don't have to. Okay, all right. So for this one, right? X is here, right? Now, I know that I still got negative 9 minus. Now, what would this have to be? If this is x squared and I already took an x out. Yeah, it's just x. Okay, you can check your answer, right? Negative 9x minus x squared. Same thing. Okay? All right. This one, now, this one's tricky because only this guy has the x, right? But look at the number, 25 and 6. Do they have a common factor? What's the largest number that goes into both 25 and 6? I'm trying to think. Nothing. That's it. All right, so this is simplest form. Okay, it's already factored out. Okay, nothing you can do about it. All right, I'm still thinking right now, actually. Okay, all right, moving on. Now, this one's interesting, right? In some ways. So let's see. Okay, now I know I can get x out, but here's the thing, all right? And this is what you should not do, all right? Maybe I should do it in red. I got x out, right? And so I say, you know what, I'm just doing whatever my teacher said. So 2, got the x here, plus 6, right? And you're thinking to yourself, well, if I distribute, I get 2x squared plus 6x, right? I'm right? Not entirely. You have neglected the 2 and the 6, because those numbers can be factored out also, all right? So what does that mean? And you can factor out the 2, so now that's just 2x, right? So look back at this, right? 2x comes out entirely, I got x, right? And then 2x times what gives you 6x? Yeah, 3, okay? And that's how that's done. Okay, how do you know? You can check your answers. 2x squared plus 6x. 2x squared plus 6x. Okay, all right, let's see. All right, try these last 3. All right, so press pause right now. Now, these are the 3 toughest questions. So if you struggle a little bit, all right, don't be too hard on yourself. All right, now for this one, I want to show you this actually. Let me break it down for you. Here we got 5, we got 2 x's, right? Minus 5 x to the third, so that we got 3 x's, like this, right? So now, focus on this, right? What do they have in common? Yeah, not just the 5, but 2 of the, not just 1, 2 of the x's. Okay, so that's it. That's it. So now we got just not just 5, right? So we got the 5, but 2 of the x's, which means x squared, parentheses. Now this whole thing got canceled out. I don't know if you realize this. This whole thing got canceled. Actually, 2 of these, right? This whole thing got canceled out. These got canceled out, right? Because it's out here. First x, second x, right? Because that's x squared. First x, second x, right? So we're not left with much inside, but that's fine, right? What am I left with here? Nothing, but that's not nothing. It's not 0. It's 1, right? Minus only that 1x here, and that's it, right? Now you can check your answers again, right? 5x squared, that's 5x squared times 1, that's 5x squared minus 5x squared times x, 5x to the third. Okay? All right. Let's see, hold on. Now, let's see. Now, this is now it's getting really tough. You know what? I'm going to stop here. Because if we have time in class, we'll go over it, but you won't see that on the regions because they're not going to give you 2 variables. All right, so, okay, all right, so that's it, all right, that's the lesson. Thanks for watching, have a good day, I'll talk to you later, bye-bye.
OMG, that was so good.